So I don't have one. So
they still can't really break HIPAA.
Is HIPAA the guidelines we got?
HIPAA is the patient confidentiality.
Yes.
Like the.
So like if you, no, that's CPR.
Like if she was my doctor and she knew some physical issue that I have, she can't go telling other people.
I can't say anything that would, if I were to talk to you, I couldn't say anything that you could identify her. So I couldn't say like.
She could say I have a patient, blah blah blah.
Right.
But she couldn't say, "Oh, Miss King."
Therapists do that. They'll tell like patients about other patients that have the same problem as them.
Yes, but they can't use their names.
Yeah.
Okay, so here we go.
Why do I know that?
Why not take the soup?
Let me find the right thing. There we go. So we got to number 6 on
Page, yeah.
Here on.
no
Yes.
270. Well, mine says 9.
Yeah,
That's what they said.
Oh, sorry, I thought it said 8. Just kidding. All right. So, just to recap, the problem is the stone is dropped. Oh, this is the ripple problem. And so it's increasing. The ripple is increasing at a rate of 1 foot per second. The radius is 4 feet. What is the rate of the total area of that outer ripple? All right. So we're almost there. We're just going to do part 6, which is substitute all the things we do know. That's all. So we are looking for dA dt. And what's the radius? I think I heard it. 4. Yeah, the radius was up here. It was given to us. I don't guess we wrote it down anywhere, but it's right. And you're right. dr dt we found it was 1, or it was given to us. So that's 8 pi feet squared per second.
I put that in the wrong square.
Oh, it doesn't matter.
I'll show it.
This is just helping us figure out how to solve it.
I don't care.
We good?
Yeah.
All right. Water
It's leaking.
is leaking. So what's that going to tell us about the rate?
Negative.
Negative.
It's gonna be slow.
Good job.
Well, maybe not. It could be rushing later.
True. It's leaking out of, well, when it says leaking, you think slow, but
It'd be like a drop.
I think of, what is that?
But
10?
3 cubic feet per second.
That's pretty fast.
Yeah.
It's like
Pi r squared.
This.
H.
in
Yeah.
a second.
In a second. That's a lot.
That sounds like a
Right,
fish
this
tank
would be
that
3
is
cubic
leaking
feet.
out.
There's 3 squares under me.
Right. And then if you were that tall, that wide, and yeah. There you go. So 3 cubic feet per second. If the radius of the tank is 4 feet, at what rate is the depth of the water changing at any instant during the leak?
3 cubic.
Okay, so the 3 cubic feet here,
Is not really.
what is that? How would I label that?
Water.
That's the what?
Rate of water.
What rate of what? Volume.
Volume.
So negative.
Now, what helps us figure out that that is volume?
Cubic.
Cubic. Good.
Would that be negative dV?
It would be. That's why I put that little minus sign there. Yes, because it's leaking out. If the radius of the tank is 4 feet,
Mm-hmm. Oh, it's a circle.
No, it's just simple.
But it's a circle.
It's
It's a cylinder.
it's a cylinder. Yeah,
Yeah,
so
like,
it has
talking about the radius.
the radius of that.
Oh.
At what rate is the depth of the
looks like
water changing?
Yes, it's a tank.
So when we talk about beautiful.
Fancy ones.
So when we talk about this cylinder, we wanted, the water's going out.
Aw.
We want to know at what rate is the depth of the water changing. So how would I label that? H. I would call it H.
It's like DD.
You could call it DD, but think
I
about
know
the volume of a cylinder. What's the formula for volume of a cylinder?
No.
Height times width times length. I don't know.
No, but it's back. Say it again.
Pi r squared.
Yes, pi r squared h. And it was on that other page where we wrote all those down.
Follow my blue line on it.
So we're going to identify all the variables involved in this problem. So we have dV dt. Oh, I guess I should say volume. I'm getting more specific than I need to get. Volume, radius. What else? One more thing. Height or depth. Either way is fine.
Same thing.
They're only calling it depth because they're talking about water.
The radius is going to stay.
You usually don't talk about the height of water.
The radius is going to stay.
Yes, very good. We actually have a radius that's the same. That cylinder is not shrinking. The cylinder has a radius of 4, period. So identify the rates that are given and the rate you wish to find.
dV
dV dt is
2, 3 cubic feet per second.
it's what?
-3.
There you go.
Oh, that's a 3.
And then what are we looking for?
dH.
And what's the units of that going to be?
Feet.
Feet per second.
Feet per second. Why not feet squared?
Because it's just high.
Because it's not
Straight
Height.
I was like,
Which one's feet squared?
area.
Area. So if we're not talking about area, it's not going to be something squared.
How many points off are these because like the units?
Units are usually like a point, but on a free response question, those are meant to be the easy points. So,
I need to figure this out.
yes,
Okay.
that's important. Plus, it's going to help you figure out what you're looking for just by looking at the units.
Okay.
Okay, number 4. We know the formula that we're looking for.
It's 2 pi r dr dt.
is it 2 pi? I thought it was squared.
That's surface area, I think,
I thought it was.
of a cylinder.
Yeah. That labeled it.
Volume
dV
pi r
dt.
squared.
That's the derivative.
Oh,
Pi r squared h. I was like, what are you talking about? That's the
I know. I was too, and I'm like, what?
I thought that's what we wanted. We wanted dV dt.
Well, we're going to change it into dV dt.
why don't we change it? We already got it
No,
there.
no.
But we have to establish what the equation is and then change it.
So any value that represents a variable that is constant, this is the first time we've had a constant,
Yes.
we're going to plug that in because it's not going to change.
Cool.
Plug what in?
The constant that stays the same, which was the radius.
So it's gonna be 16.
The radius of that cylinder is always 4.
It's
Yeah.
16 pi h.
Right.
Oh. Wow.
You know, I gotta run the derivative of that.
Well, yeah, we can.
Now implicitly differentiate both sides. So dV dt equals
2 pi.
you're,
2 pi r.
Oh, no,
Oh,
you're
that.
doing this.
16 pi dH dt.
Very good. Now we plug in things.
What are we plugging in?
Yeah, what are we plugging in? Look back to what we
dV
did.
dt is equal to -3.
Yes.
Is equal to 16 pi of no clue.
Wait.
Well, this is what we're looking for.
How did you get -3?
Oh, do we think that
-3 was listed on number 3.
Oh.
So now we divide by 16 pi.
Fun.
Yep, and that is feet per second.
Woo.
Yeah. I feel bad for that tank. That tank's probably expensive. Probably efficient.
Right.
Or
Well,
they're just-
maybe they're draining it.
Yeah. To get newer water. It's probably stale
Clean
water.
water.
Clean water. Yes.
I was like, those fish tanks that are cylinders, those are lead. Like,
Can they be fire too?
Yeah.
Okay.
like, isn't there one at that fast food shop? Like,
There's everything at Bass Pro Shop.
Yeah,
They have fudge.
They have a restaurant.
They have fudge? Well then.
Right. They have everything.
They not like they have a hotel or anything.
They do have a hotel.
No, they have like
It's
a
expensive.
a restaurant.
My parents went for their anniversary for this thing.
My parents for their
Have you been on
anniversary.
that
tours.
walk?
I've never been there.
Really?
Have
Hey,
y'all been on
Cone.
that
One
walk?
time my mom went up there, the lights and the bridge were on.
Hi, Harvey. A cone has a diameter of 10 inches. A cone. So, cone.
There you go.
Yes. Has a diameter of 10 inches, height of 15 inches. Water is being poured into the cone.
It's positive.
So, yes.
Yeah.
So, it's positive. So that the height of the water level is changing at a rate of 1.2 inches per second. And that's a rate. So, how would I label that?
Is it DV?
DV.
Is that volume?
No. DH?
D8.
Yeah. It's the height. Sorry. At the instant when the radius of the exposed surface area of the water is 2 inches.
Ooh, we're working there.
Ooh. At what rate is the volume of the water changing?
DVDT.
Yeah, so we're looking for dVdt.
Hey, our radius is 5.
Okay, so what are the things that we have?
Volume.
Volume.
We have diameter/radius.
Diameter, which we can find radius from, right?
Yeah. Height.
Height.
Is that it?
Yeah, I do believe that's it. Okay, are any of them constant?
Diameter and
Height.
Height.
Okay. And the height of 15 inches.
the cone's height is measured in water.
Is the water's height
Oh, yes.
or the diameter of the water constant?
No, but the
No, because it's
Radius
increasing.
wouldn't be constant either.
I
So
thought
neither
the cone-
one's going to be constant.
So nothing.
Nothing. Now, of whatever container we're plugging it into, yes, it's constant, but we're talking about the water.
I spelled that super wrong.
Identify the rates that are given and the rate you wish to find.
The rate of height.
DHDT is 1.2 inches per second. Alright, babe.
I don't care. It's just the rate of height, which is incorrect, but.
It's okay. And what are we looking for? Faith?
DVDT.
Okay, everybody.
DVDT.
It's going to be.
Question mark. This is
Okay.
feet squared, finally. Not
No,
cubes.
this is volume.
I got it.
It's volume, it's cubed.
What is it cubed?
Inches.
Inches.